Node state and attribute. It identifies the nodes that function as traffic aggregators and nodes that are being impacted by high workloads. High workloads could be inclusive of nodes that have incurred high CPU or low memory states. Naturally, nodes that are aggregators are preferred over nodes experiencing high workloads. Nothing but how much that it is carrying, traffic is getting carried in that particular node, that it is going to be checked. Node energy. It avoids the nodes with low power, so the battery powered node that is running out of energy can be avoided and life of that node and the network can be prolonged. It's a very important thing. So it checks the node power. If the power is going to be less, which it cannot be getting forwarded. So it thinks based on that the power, if the full power is going to be there, so the node can get transmitted, the data can get transmitted to the prolonged one. Only the throughput of that, if you are going to consider, it provides the amount of throughput for a node link. Often nodes conserving power use the lower throughput. So this matrix allows the prioritization of paths with higher throughput. Because of that, prioritization is going to be there. Finally, we will come to the authentication and encryption on constrained nodes. Here we have another two protocols, you can say, or security protocols it is going to be. IDF working group has focused on two things, that is ACE and DICE. ACE is nothing but authentication and authorization for constrained environment. This working group again is tasked with evaluation of the applicability and existing authentication and authorization protocols and documenting their suitability for certain constrained environment use cases. This ACE work group will focus on COAP with a datagram transport layer security, that is DTLC protocol. The ACE working group expects to provide a standardized solution for authentication and authorization that enables authorized accesses for getting the data, inserting the data, posting the data, deleting the data to resources identified by the URI and hosted on resource server in constrained environments. An unconstrained authorization server performs mediation of the access. Second one is the DICE, where the new generations of constrained nodes implementing an IP stack over constrained access networks are expected to run on optimized IP protocol stack. DICE is the DTLC in constrained environment. What is DTLC? It is datagram transport layer security in constrained environment, DICE. Our group focuses on implementing DTLC, DLS transport layer security protocol in their and in these environments. The first task of DICE working group is to define an optimized DTLS profile for constrained nodes. In addition, should also be considering the applicability of the DTLS record layer to secure multicast messages and investigating how the DTLS handshake in constrained environment can get optimized. It is a very simple concept. DICE works on like handshaking signals where the IP is going to be there. Then ACE works on non-handshaking signals. Okay, that is the datagram protocols. Profiles and compliances. Coming to the last part of the IoT, IP and IoT data, the protocols you can say. So profiles and compliances. Profile definitions, certifications and promotion by alliances can help implementers to develop solutions that aggregate interoperability and interchangeability of the devices. As you will be going to see that in future of this IoT, so these are very essential things. Without the certifications of the protocols, that we cannot be able to use it. Okay. Some of the main industry organizations working on profile definitions and certifications for IoT, constraint nodes and networks. Four are there here. First one is Internet Protocol for Smart Objects, IPSO alliances. Then Wi-Fi alliances, Thread is there. Next IPv6, ready, logo is. What is this Internet Protocol for Smart Objects? This alliance initially focused on promoting IP as the premier solution for smart objects communications. Today, it is more focused on how to use IP with the IPSO, that is smart objects. Alliance organizing interoperability tests between alliance members to validate that IP for smart objects can work together and properly implement industry standards. Nowadays, IoT is booming, and without the smart objects, IPs, with IP, we cannot have much applications. Simple applications are going to be getting conducted or executed in the IoT. But if you are going to use this IP also along with that, it will become large and it is going to be more useful also. Okay. Wi-Fi alliances. Wi-Fi's main focus is on the IEEE 802.15.4G protocol and its support for multi-services and secure IPv6 communications with applications running over the UDP transport protocol. Very important concepts. So there are, again, this is a Wi-Fi, is another alliance where focus on this particular, that is IoT protocol. This is 802.15.4Z, where it supports for multi-services, more than one services are going to be there, and the secured IP network, that is IPv6 communications, and with applications which you will be going to use is UDP applications, that is a transport layer. It's very good or important.